Hey all, my name is Joseph Patrick and I'm going to take you through this Cropsense project of ours. I'm with my friend Kisa Ben Esla, and Cropsense is an AI tool that helps farmers to diagnose their crops and provide recommendations, as well as the where to buy those recommended pesticides and other mitigation measures. So this is a demo video of our Cropsense. It shows how basically we upload the image and it provides the recommendations and where to buy the recommended pesticides. I think you should see everything in slide because it's kind of somehow big to be presented in this short period of time. Then here we are going to look at the problem space and purpose. First of all, the problem that we are solving is that farmers fail to diagnose their crops on the time. So they don't, even if they do that, to get the right pesticide choice and their guides, it is very hard. That's why we just decided to do this AI tool to give the recommendations on time, anytime they can use it, and all that. That's the reason why we use the AI. We use the AI just because it is very precise and it is affordable and available anytime. So the stakeholders we shall be working with, they are farmer cooperatives, agriculture associations and institutions, agri-tech companies and agro dealers. The impact is to reduce the misuse of pesticides, is to reduce the money that people spend in getting the agronomist and others. So the stakeholders, the users and ecosystem actors, actually users are farmers of course, and farmer cooperatives and agro dealers. Then the secondary stakeholders, agriculture institutions, research institutions, universities, and all that. In ecosystem laws is what each part of our ecosystem will be doing. Data suppliers, they provide for us agronomic databases and access to other data we use. API consumers, like e-commerce platforms, yeah, they use our API just to use our recommendations, maybe farmer management apps and all that. Then also we have algorithm designers, who are us developers, have platform maintainers, cloud service providers. So we have government entities which will be helping us in all this. There are data protection and privacy. There is a Ministry of Agriculture and Animal Resources and Forestry. Let's now talk about data sources and value. We have data types, which are the type of data we used. We used crop images and text-based agronomic knowledge and agronomic rules. I can say also the sources was open datasets and other journals, agronomic knowledge banks and all that. In processing pipeline, we collected data, cleaned it. I remember especially in agronomic knowledge banks and journals we use just to get what is important, and then annotation. And in cleaning we just arranged it the way we wanted. Annotation, just validation and storage. um Ethical and legal frameworks, I can't say that we used a lot of things as long as it was followed, was following personal data privacy organization laws and regulations of national data protection acts. Yeah, in about informed consent, we never just had any data we collected which required informed consent. Our solution and AI system description, we used of course computer vision. We used the disk visual encoders. uh, the input is image, we just put image, and then output we get top key diseases based on confidence scores. And in architecture, our architecture I can say is hybrid. It combines three based encoders plus knowledge graph, reasoning and inference layer for recommendation, as you see down there. And then we use the GradCam for visualization of the most focused parts of our image. So the key metrics and evaluation we've used are, first of all, technical metrics is a technical evaluation, embedding quality, how how embeddings represents well the images. Then you have latency, uptime, and error rate, how errors are measured. We have also user-centric metrics. These are how users interact with our systems, like engagement time and all that. We have ethical metrics, how fair is our system, how transparency, how it respects data privacy and consent. And also then we have business metrics, how customers are increasing, lifetime value, partnership conversion, and revenue growth, and all that. So we also have unfair advantages and differentiation. This is the uniqueness of our system. Proprietary agronomic knowledge graph. Our system is built on the unique self-curated dataset, which that we collected data in different places and then we combined them. And also our image dataset is very unique, and yeah, that's what I would say. In modular AI architecture, also our architecture is different. Mostly people use LVM, other people use CNN or what, but for us we combine different non-visual encoders, and then we combine them just to provide a very good working system. Then we have also integrated ecosystem edge. It just combined diagnosis and e-commerce integration. So the following are our channel of distribution. First of all, how we shall be reaching out the customers. I can say it's through agri-tech webinars, social media campaigns, physical outreach in farmer communities and all that. Then delivery channels, our system is accessible online and via API integration for partner systems. Partnerships, we have NGOs, we have agricultural institutions and universities. Then how we shall keep our customers, continuous model updates, and farmer engagement in community to how they are enjoying our system. Revenue stream, have four. I can say direct revenue stream is by subscription. After free trial, our system will start to have different brand subscription per use. We have API per use to people who use our API in their systems. Then in indirect revenue models, data as service, we shall be offering access to our datasets. People will be paying, and then consultation and training services. We have also commission-based earnings, basing on our e-commerce platforms that are integrated to our system. They can be giving us some money for commission, because we shall be kinda letting their business become easy. Validation streams, sponsored research collaborations will be also another way of getting revenue. So the key resources that we shall need, we have human resource AI engineers, even though we should need another to just make it big. Machine learning researchers, data scientists of course to get data, and we needed what user interface designers. We tried our best, but to make it big, I think we shall need also some other, because we are still in building. We have to make it so big. In technical infrastructure, how we need where to store our system to be working worldwide. And then data infrastructures are those ones. We need data to keep training our models. Then financial resources, we need grants, we need fundings, yeah, to make it big, and getting financial resources to sustain our human resources. The activities that we shall need, among the key activities, there is model lifecycle activities. Getting data, this is what we have done. Laboring model training and all that. Product development, there is operation activities like model monitoring, model drift. Yeah, we have governance and compliance. I have not yet done this, conducting AI audits by government, and just giving us like reports to allow us just continue working how we are working. Then customer focused activities like technical support and user feedback groups, just going to check how our system is working out there. It will be very important key activity. These are our different partner categories. have AI and cloud providers, of course, Google Cloud and AWS. So far, we are using Railway, where we just uh, deployed our system. Data partners, people who help us to give us data. Ethical oversight partners, regulatory agencies who help us to check how ethically we are working well. Distribution partners help to take this system to people. Yeah, strategic collaborators, e-commerce platforms, and others. Now let's talk about the cost structures, how financially we are going to spend on our system. First of all is data costs. Mostly we need to access different data sets from different organizations or private institutions. So we need data collection, cleaning and labeling, storage. We estimated $300 per year. There is computation and infrastructure costs. That is GPUs, TPUs for training and all that. We estimated 1,500 US dollars. There is human resource costs, which are our people who have to help us. Estimated 1,000. Compliance and legal cost we estimated 200. Then marketing and distribution we estimated 500 US dollars. Maintenance and scaling costs we estimated $500. Let's go on governance and ethic compliance. First of all, governance. Here we are talking about how we are going to be aligned with governments, and also how we are going to ethically be performing outside there, because we should need also that ethical conduct of our model, how we assess it, how well it prevents people's privacy and all that. And then governance model, oversight by a dedicated AI and agronomy board, have to just be to have legal advisors, to have agronomists who are very good in that. And then we have to talk about fairness and bias auditing, to check the prediction or embedding performance that our model provides, and try to assess whether it aligns with what exactly is out there. We take the reality and test and our predictions and see how our system is fair, how biased is it, to keep just training and adjusting. um Explainability tools we used, as I've said before, we used the .com++ for visualization and allowing farmers to see how where our model like checked. Legal and ethical frameworks, we shall be using Personal Data Privacy Association of Uganda, UNESCO AI Ethics and others. Accountability, we define laws per everyone in our group so that everyone can be accountable of what he's doing. Now let us talk about how our model will be able to accommodate growth and sustainability. First of all, modular cloud-based microservices will allow the expansion to regional servers based on cloud services. Continuous learning, this model will be updated regularly on new diseases and pests, and increasing the crops that we are working with. Localization means that our model diagnosed many local crop diseases. I can say, yeah, we just based on many available local diseases. Then sustainability, it promotes eco-friendly farming, reducing pesticides overuse. And then backup model in our resilience, cloud infrastructure will help us to have uninterrupted services. So about intellectual property innovation, our idea is patentable, as it provides a full pipeline of crop diseases compared to others, and also treatments recommendation. It provides all that full pipeline to how it just diagnose crops, which is very important and which should be given intellectual property. Our team is me, Joseph Patrick, dataset collection and presentation lead, and also Mukisa Ben Ezra, technical lead. He was just more of technicality, and me, I was in charge of mostly dataset collection and presentation, even though we used to work together in technical lead. Yeah. Any question, you can reach out to us. Our contact is up there in the first slide. Thank you.